The first type of cable we want to look at is a simple zip cord. The zip cord is basically two pieces of 3mm jacketed cable connected together. I can slit them and show you what the individual cables look like very simply. You can see it's just two 3mm jacketed cables with a web holding them together. In order to strip them, we can use a standard wire stripper to take the jacket off the cable. The way we do it, however, is different than we strip wire. When we strip wire, we cut into the cable and pull the insulation off. We don't want to do that with fiber. We want to cut through the insulation very carefully so we don't nick the fiber. And then we're going to use our fingers to take the jacket off. So the first thing we do is we set the cutting depth of the strippers. And on these strippers, it's adjustable. There's another type of ergonomic stripper that is preset. We'll use this one because it has both a cutter for the jacket and a stripper for the fiber. So what we want to do is to just squeeze tight, cut through the jacket, then grab the jacket with our fingers, twist it, and pull it off. We want to make sure that we do not nick the fiber. Now, into the cable, you'll see some Kevlar strength members. We call it Kevlar. That's a DuPont trade name. Its official name is an aramid fiber. And then the buffered fiber. You can see this fiber is 900 micron buffered, and it's color-coded white. If I look at the other cable as part of this, there's our Kevlar again, and this one is color-coded blue. So we have a blue fiber and a white fiber, which makes it easy for us to identify which cable is which. Now, when we are going to be terminating this, we would be stripping the fiber and cutting back the Kevlar to attach a connector. If we're going to be splicing it, we'll be taking a lot of jacket off, perhaps a foot or foot and a half, and stripping the end for cleaving and splicing. So this is just a standard type of cable. There's a lot of this cable used in things like computer rooms. It's used as patch cords to connect up from patch panels to equipment, or from a wall outlet to the desktop. So this is a very standard type of cable. Generally speaking, this cable is laid in trays or not pulled, but you can pull it. In fact, it has a pulling tension of about 200 pounds. What you want to remember is to not pull it by the jacket. And I'll show you why. If I grab this cable by the jacket and pull, I can stretch the jacket. And when I release it, you can see it bundles up. If we zoom down on the cable itself, you can see that the cable is all rough because of the Kevlar that has been bundled up as the jacket contracted after we stretched it. In fact, if I cut this with a pair of scissors, and by the way, you should not do this with your Kevlar scissors, it dulls them, but I want to show you how to do it anyway. If I cut this, you can see we can grow Kevlar. You can still see the Kevlar pushing back out. Now, if we test this cable, we'll find this cable is very, very high attenuation, because of the fact that the Kevlar bundled up inside the jacket is putting lots of stress on the fiber. We never want to pull a fiber optic cable by the jacket unless it's a cable that's specifically designed for pulling by the jacket, which means that the jacket is attached to the strength members. Unless you hear otherwise, always assume that we're going to pull the fiber optic cable by the strength members, and I'll show you how. To pull a cable, always pull by the strength members, even a simple cable like this Zipcord. And I'll show you how to pull it. It's really quite simple. For the Zipcord, just split the two cables, remove the jackets, and immediately cut off the fibers. You can use the stripper to cut off the fibers. Cut off the fibers and discard them, because you do not, under any circumstances, want to pull the cable by the fibers. You will harm the fibers. They're not designed to pull. These strength members, we always call them Kevlar, but it's actually a DuPont trade name for an aramid fiber. The Kevlar strength members are very strong and capable of being pulled as much as 200 pounds. So what we do is we take the jacket off, we cut the fibers off, and then we bundle up all the Kevlar. Now, because there's twists in the Kevlar and twists in the cable, we always pull with a swivel. It's also important to pull with a swivel if you're going to pull with a rope, because the rope is twisted, and as it pulls it will untwist, and it will put the twist into the fiber cable and perhaps creating undue tension on the fiber. So always use a swivel. This is a simple little swivel. And what we do is we tie the Kevlar to the swivel. Now we're ready to pull, almost. The problem is that the Kevlar is really very strong, but it's also very slippery. So if we just tie it to the swivel, once we pull it and let go of the tension a few times, it will untie immediately. So what we do is we tie it to the swivel about 1/2 inch from the end of the jacket. Just a couple of knots works fine. Pull the Kevlar back along the jacket and then tape it with simple electrical tape. And we want to make sure that we tape it to keep it from unraveling, but we also want to tape it to make sure that the jacket of the cable does not get hung up anywhere in the conduit or inner duct that we're pulling it in. So let's tape it back a few inches from the end. And now we have a cable that's ready to be pulled with up to 200 pounds of tension. We're ready to pull that cable.